Good day, class. You are welcome to the tutorial on brake drum, on the design of brake. Now, let us take a look at this question 5. The question says, a double shoe brake shown in figure below is capable of absorbing 1400 Newton meter. The diameter of the brake drum is 350 mm and the angle of contact for each shoe is 100 degree. If the coefficient of friction between the brake drum and the brake lining is 0.4, the first question here is that we are to calculate the spring force necessary to set the brake. And the second question is the width of the brake shoe if the bearing pressure on the brake lining is not to exceed 0.3 Newton per millimeter square. Now let us set out our given. Given in the question here, we are given the braking torque TB, which is equal to 1400 Newton meter, which is given as 1400 times 10 raised to power 3 Newton millimeter. Then we're given the diameter of the drum to be equal to 350 mm, and the radius will be 175 mm. Then next, we are given the angle of contact 2 theta to be equal to 100 degree. Now we need to convert it to radian. We do so by multiplying it by pi over 180, and this gives 1.75 radian. Also, the coefficient of friction mu is given as 0.4 and the bearing pressure is given as 0.3 Newton per millimeter. Now, these are what we are given. Now, the first thing we are to calculate here is we are to calculate the spring force necessary to set the brake. Now, say let S be the spring force that is necessary to set the brake in action, which is this one and this one. Then let us take R1 as the normal reaction, as the normal force on block 1. Then Rn2 as the normal force on block 2. Then Ft1 as the tangential force on block 1. Then Ft2 as the tangential force on block 2. Then from here, we have seen that the angle of contact 2 theta is 100 degree. Therefore, we need to calculate the equivalent coefficient of friction given by mu prime is equal to 4 mu sine theta over 2 theta plus sine 2 theta, which is equal to 4 times 0.4 times sine 2 theta is equal to 100, meaning that theta is equal to 50 over 2 theta in radian is given as 1.75 that we have calculated before, plus sine of 2 theta, which is 100 degree. If you press calculator for this, you have 0.45. Then the next thing we need to do here is we take moment about O1, we take moment about this point O1. Then in doing so, we have moment about O1. Then we have the spring force S multiplied by 250 plus 200, which is 450. This one generates anti-clockwise moment. It will be multiplied by 450 is equal to the normal reaction on block 1, Rn1, multiplied by 200. That is, this normal reaction here generates clockwise moment, and its distance from this place is this one, which is 200, plus the tangential force on the block 1 multiplied by its distance from point O1. Now, the tangential force, its distance from point O1 is something like this. So, but we know that from here to this place is from here to here is the radius of the drum, which is 175. To get this one now, it will be radius of the drum minus this 40. Then we'll have 175 minus 40. Then we'll have 450 S is equal to the Rn1 is Ft1 over mu prime multiplied by 200 plus Ft1 multiplied by 135. Then we'll have 450 S is equal to Ft1 over mu prime is 0.45 multiplied by 200 plus Ft1 times 135. Then from here we have 450 S is equal to 200 divided by 0.45. This gives 444.4. Then Ft plus 135 Ft. Then we have 450 S is equal to this one plus this one gives us 579.4 Ft. Then let us make Ft the subject of the formula. Ft will be equal to 450 divides 450 S divides 579.4, and this gives 0.776 S. Now let us take moment about O2. In the same manner, in this case, the spring force S generates clockwise movement, and its moment is S times 450. Then the tangential force Ft2 also generates clockwise movement, which is Ft2 multiplied by its distance, which is 175 minus 40, which is 175 minus 40 is equal to Rn2 multiplied by 200. Then from here we have 450 S plus this one is 135 Ft2 is equal to Rn2 is Ft2 over mu prime, then multiplied by 20. Then we have 450 S plus 135 Ft is equal to Ft2 over mu prime is 0.45 times 200. Then we have 450 S plus 135 Ft is equal to 200 divided by 200 divides by 0.45 is 444.4, then ft. Then you collect the like terms. We have 450s is equal to 444.4 ft minus 135 ft. Then we have 450s is equal to this one minus this one will give 309.4 ft2. This is ft2, ft2. Then making ft2 the subject of the formula, we have ft2 is equal to 450 s divides 309.4, and this gives 1.454 s. Then from here we know that torque capacity TB is equal to the sum of the two tangential forces Ft1 plus Ft2 multiplied by the radius of the drum. And this torque is given as 1400, which is equal to Ft1 from what we have derived is 0.776 s plus Ft2 is 1.454 s. Then multiplied by the radius. The radius is 0.175. When you simplify this one further, you have 1400 is equal to 0.390 s. Then from here, 25 s. Then from here, s will be equal to 1400 divides 0.39025, and this gives 3587 Newton. Now, this is the first part of the question. Then the second part of the question says that we should find the width of the brake shoe. That is the second part of the question. We say let the width of the brake shoe be B. Then from here, we calculate the projected area of one shoe. Projected area of one shoe AB is given by this width B multiplied by here this place, which serves as a chord in this circle, and the length of this chord is given by 2r sine theta. Then when we substitute, we have AB is equal to B multiplied by 2 times R. R is 175, then sine 50. When we simplify this one further, we have it as 268B. Then we know that Rn1 is equal to Ft1 over mu prime, and Ft1 is 0.776 s over 0.45. That is Rn1 is equal to is 0.776 multiply S. Our S is 3587 divides 0.45, and this gives 6186 Newton. Then we also do the same thing to Rn2. Rn2 is equal to Ft2 over mu prime, which is equal to 1.454 S over 0.45, which is equal to 1.454 times S. S is 3587 over 0.45. When you do this, it gives 11,590 Newton. When you compare Rn1, which is 6,186, and Rn2, which is 11,599, here we are going to consider the maximum value of the Rn, which is Rn2, and that's what we are going to use for the design of the shoe brake. For this reason, we use Rn2 since it is higher than Rn1 in our design. For this reason, we know that the braking pressure is equal to R normal reaction. We are going to use Rn2 over the projected area. And the braking pressure given is 0.3 is equal to Rn2, which is equal to 11,590 over the projected area, which is 268 B. Then from here, we will simplify to get our B. We have this one as 43.25 over B. This implies that our B is equal to 43.25 over 0.3, which is equal to 144.2 millimeter. Thank you very much for being patient with us. So we are going to meet in the next tutorial question, that is question 6.